Hi everyone, my name is Anson Lee, JAI's Pre-Sales Technical Manager for Asia. Today, we'll be talking about the blemish compensation function found in all GoX cameras. This is a function which is relatively common in high-performance cameras, but JAI includes it in all cameras, including budget-oriented models like the new GoX series. Allow me to explain why this function is important for machine vision cameras. The image sensors used in today's industrial cameras are never perfect. If sensor manufacturers were to discard any sensor containing a few defective pixels, yields would drop dramatically and sensors, as well as cameras, would become much more expensive. So instead, sensors are allowed to have a modest number of pixel blemishes and still be considered acceptable. This includes dead pixels, pixels which stay black or nearly black at all times, and hot pixels, pixels which stay at the same white level regardless of the image. To keep these blemishes from affecting the image quality of the camera, JAI identifies the location of any white or black sensor blemishes during factory testing and feeds these locations to a compensation function that is built into the camera. When the camera is delivered to a customer, the built-in routines use the values from neighboring pixels to assign an approximate value to the pixels in the output image, where the blemishes would be, and the result is a very clean and usable image for your machine vision application. However, blemishes don't just occur during the semiconductor manufacturing process. New white blemishes can also occur after the camera is in use. Typically, the appearance of a few new hot pixels is the result of extremely long or bright exposures. But extensive use of the camera, changing temperature conditions, or even the impact of cosmic rays can also generate these blemishes. For this reason, JAI includes a blemish compensation function designed to identify and compensate for blemishes that appear after the camera leaves the factory. The number of pixel blemishes that can be compensated varies depending on the camera series. For example, JAI's GoX series cameras allow up to 256 pixels to be compensated, while JAI's 45 megapixel Spark series cameras include the capability to compensate over 3000 pixels if necessary. Now, let's look at how you would use this function if it is ever needed. I say if it is ever needed because this is not the function that you will necessarily need to use very often. If you are preparing a camera to place in a new system, you might run this once to be sure that any new blemishes had been compensated. But then, unless the system was exposed to conditions likely to cause new blemishes, you would simply leave it alone at that point. So first, let's open the eBus player for our JAI GoX series camera, which for this demo is the GoX 5103M USB model. Since we are looking for white blemishes, we want to make the image as dark as possible so that the video level of the blemishes will clearly stand out compared to the very low pixel values you would expect in a dark image. We can use a lens cap as a shield to achieve this dark condition. Now, visually, you might not notice any white pixel blemishes from the screen. This is a relatively new camera, and there may be none or only a few blemishes that aren't already being compensated by the factory routines. But let's keep going anyway. We'll first set our acquisition frame rate to something close to what we would use for our application so that the effect of any blemishes will be based on close to real-world conditions. And we can let the exposure time be whatever the frame period would be. For the purpose of this demo, we have intentionally set the frame rate to 1 Hz to generate blemishes. Next, we set a blemish detection threshold, which can be from 1 to 100%. For now, we'll leave this at the default, which is 10%. This means that any pixel in our black image that is showing a video level above 10% will be considered a defective white pixel that needs to be compensated. In other words, in an 8-bit dark image like this, where depending on our black level setting, we would expect all of our pixels to have very low values. If our detection routine finds one with a value that's more than 10% of the way between our black level and our maximum, it will be identified as a white blemish.
Now, we enable the automatic blemish detection feature of our blemish compensation function. When that is running, we can look at the blemish compensation number field and see that our function has detected 9 blemishes exceeding our 10% threshold. As part of the automatic detection, it has also saved this data to the camera's internal memory so that these blemishes will be automatically compensated going forward. If we are interested, we can now examine this in more detail by clicking through the blemish compensation index field. For each index from 1 to 9, we can see the position X and Y locations of each blemish until we reach index 10, where the positions are shown as -1. This tells us that no more blemishes are detected from index 10 onwards.
So that's it for this demo with regards to the blemish compensation function. If you have more questions, please complete the form on JAI's website, www.jai.com, and we'll be in touch shortly. Thank you.